Hello, everyone. Thank you for joining today's session. The topic of this session is delivering the future of networking with hyper-scalable connectivity. My name is Liang. I'm a product manager in Epsilon and based in Singapore. Let's get started. We are covering a few topics today. Who is Epsilon? The landscape of complexity of service providers in Asian market. What is programmable telecom? The traditional networking versus network as a service model. We also share a use case of API networking with DC Connect, a leading SDN player in Greater China. We finished the session with a platform demo. First, let me introduce Epsilon. We are a global connectivity provider that is simplifying how business connect applications and data in the cloud through our network as a service platform, Infini. We are focused on simplifying connectivity service for our customers and partners. We leverage our API and software-defined networking and continuously investing in research and development to digitize the whole lifecycle of connectivity services into our Infini platform. With this, our customers can focus on their business and digital transformation projects. We were founded in 2003, and our headquarters is in Asia. So we have been operating in Asia for more than 10 years. Let us share with you the landscape of API and telecom in Asia. According to the Global Interconnection Index report by Equinix, APAC is the second fastest growing region for interconnection bandwidth. The compound annual growth rate, CAGR, is projected to be 47% between 2019 to 2023. Enterprises in Asia are seeing the interconnection as a business enablement resource. While this is exciting, the enterprise needs to have a clearly defined strategy to navigate the complex landscape and fulfill the needs of its stakeholders. In Asia, enterprises start to migrate to local cloud regions instead of North American region as before. There are unique rules and regulations in each market, unlike Europe and North America. Interconnection knowledge gaps are especially prominent, and local connectivity market is challenging due to the not fully liberalized telecom market. Although there are many challenges, interconnection is addressing the needs for better access to services, such as reduced latency and reduced cost. These are key business enablement resources. Is there a better way to embrace the challenges and opportunities? Yes, there is. Introduce programmable telecoms. As Epsilon is a telecom service provider, the strategy is clear. We need to support programmable telecom. What with programmable telecom, more stakeholders can create value and solve problems using telecom service. We need to present telecom services and functions via API application programming interfaces to the development community and enable independent development of applications leveraging telecom. Programmable telecom and APIs are not new concepts. In the 1980s, telecom industry is looking for intelligent networks. In the 1990s, voice functions APIs start to emerge. Parley is the first bold step to present functions to developers instead of telecom experts. In early 2000, Java APIs for integrated networks, GEN, is published. Then the development continues to provide additional programmable functions such as messaging and voice. IntelliPeer is a pioneer in the area in 2003, and Twilio has built many use cases and success stories using voice and messaging APIs. The data networking evolved its programmability also over this period. We have seen FOSS's, Forwarding and Control Element Separation Working Group, from IETF in 2004. IETF is Internet Engineering Task Force, the leading standards organization. This is the first step to drive the separation of data plane and control plane and it builds the foundation of software-defined networking, the SDN. OpenFlow in 2008, as an industry standard SDN implementation, built more programmability in the data networking. We are now at a point where we have evolved to sets of APIs supporting voice, messaging, and data services. There are about 7 sets of APIs having emerged. There are telco standards. These are developed by industry bodies such as MEF and TM Forum. Independent telcos, developed by the telcos like Epsilon, Telstra, and others. Vendors API, developed by the equipment and software manufacturers like Juniper and Arista. There are also IX API by the internet exchanges, cloud service APIs covering the infrastructure as a service, platform as a service, and software as a service, and community API for specific requirements. We are excited to contribute and participate in this set of APIs development and adoption. We have actively participated in the cloud and IX community to really make sure the standardization of the APIs are for the market. We have covered an overview of a programmable telecom and sets of APIs in the market. Let's see how API is differentiating a traditional network model and a network as a service model. The traditional service functions are evolving from old technologies such as ATM, frame relay to IP and MPLS, but it is separated by different layers on the left, such as different packages, different value-added services, and so on. It poses challenges for operators and consumers to efficiently and effectively utilize the resources with automation. With APN and the SDN adoption, these services have evolved to be easily consumable on the right, such as analytics, orchestration, and full lifecycle management. With the adoption of NaaS model powered by API compared to traditional network model, customers enjoy the 6 characteristics of controllability. The telecom services are visible, controllable, priceable, orderable, deployable, and manageable. These characteristics would cover the whole lifecycle of telecom service and make it easily accessible. We're happy to see the progress in the industry, and our customers and communities are getting a better, easier, and accessible telecom services. We have covered a lot on the market dynamics on telecom API. Let us give you a quick overview of an example, Infini by Epsilon. Infini is a network as a service platform that provides access to on-demand connectivity with visibility over network performance. Infini is providing global connectivity through Epsilon network and partner ecosystem. As you can see, there are many leading cloud service providers, network service providers on Infini, and customers would be able to connect to them. Data and voice services are available in Infini. The most common use cases are data center interconnection, cloud connect, remote peering with internet exchanges, and voice number ordering and porting. This is an overview of Infini-enabled services. It is an end-to-end global connectivity and intelligent communications platform for all your data and voice needs. You can interconnect with over 200 data centers on Epsilon network and extend access to multiple cloud service providers and internet exchanges from anywhere around the globe. That is an overview of Infini, Epsilon's SDN platform. We are presenting a telecom API use case with DC Connect, a leading SDN player in Greater China. Since 2018, Epsilon and DC Connect partner to interconnect software-defined networking platform, drive SDN adoption in China. The partnership is the first time for 2 SDN platforms to be interconnected in China via a bilateral API integration. DC Connect's customer in China can gain instant, and seamless access to Epsilon's global fabric when they use DC Connect's SD Cloud Express platform. It enables users to interconnect with Epsilon's network and reach to the global locations, whether it is a data center, commercial building, cloud location, and internet exchange point. DC Connect also enables Epsilon's customers and partners to interconnect in major cities in China, including Beijing, Shanghai, Guangzhou, and Shenzhen. Infinity users can instantly connect to China nationwide SDN network with extended access to more than 18 data centers and 11 cloud service providers, including Alibaba Cloud, Amazon Web Services, Tencent Cloud, and Huawei Enterprise Cloud. We have covered the Asian market landscape, market evolving to a programmable telecom powered by API, and we did a comparison for a traditional networking model and a NaaS model. We also shared a use case that we have developed with DC Connect on API integration. Now it's a time for an Infinity demo. Now, if you are open to the Infinity web page, you will be able to log in with your username and password, and you'll be able to click sign in. You can get the account from your account manager, and you can also register by yourself. Our account team will be able to get in touch with you. Once you log in, you are landing to this networking home page. Here is an overview about the service that you have available in Infinity and the ports you have ordered. The ports is an Ethernet physical ports on Epsilon's equipment. And using these ports, you can connect to many Epsilon services. On the top, there are key partners Epsilon have, and you can connect to all of them from different locations. The use case we are demoing today is a data center connection to the cloud. It's a cloud connect use case in Singapore. First, you need to buy a new port, and you will select the region that you are connecting from. In this use case, we're selecting Singapore and Equinix SG1 as the originating ports to connect to the cloud. In this case, we're selecting 10G ports. We have two options, 1G and 10G ports. We are also selecting the contract duration. We're supporting three options, 1 year, 2 year, and 3 year. For the cabling, Epsilon can order on behalf of the customer, and customer can manage themselves. So it's very flexible. And you can click buy after you have finalized the configuration. Then you can accept the terms and conditions, and you can buy the ports. Once you click the buy port, you'll be able to receive an email on this port has been purchased to acknowledge your order, and you can return to my ports in the Infinity. In the My Ports page, you will be able to see the ports available to you, and you can use these ports to make your connection to the endpoints. I'm just showing an example where you can connect to. In the community port session, you can have a full selection of carrier partners like NTT Communication, Orange Business, and a voice customers, voice partner like Telenor, Smart IPX, and cloud service, which we will demo later. So in the cloud service, you need to click the service. You can click add service. In this case, we are provisioning a Cloud Connect service. So you select cloud networking in the dropdown in the tab. And you can select the Asia Pacific as a region since we are connecting to Microsoft Azure in Singapore. You can see the Microsoft Azure is there. You can click. Then you can select where you are originating the traffic. The origin port of the traffic is also in Asia Pacific, in Singapore, and in Equinix. You can select the port you just ordered, which is the 10G port. Then you will be able to select the network protection configuration. We support both network protected or unprotected configuration. In this case, we are selecting a network protected configuration. Here you will be able to select the duration of the contract and the speed of the service. The contract is supporting from 1 month all the way up to 3 years. And you can select the speed based on the infrastructure is able to support and based on the port speed that you select. So in this case, we're selecting a 200 meg link virtual connection to the Azure. Now you'll be able to see the price and you can configure and buy. In this page, you need to key in your service name. In this case, we select SG Azure 200 meg for the record. And you need to select key in your Azure service key, and you can input your customer VLAN later. So the Azure service key is numerical in the Azure portal. Here's how you can get it. In the Azure portal, you click the Express Route Circuits, and you click Create Express Route Circuits. Here you will be able to specify the information required to create the circuit. You key in the circuit name, you select the provider name. In this case, you select Epsilon Global Communications. And you can select the peering location. Since we are in Equinix SG1, we are selecting Singapore as the peering location. Then you can select the bandwidth. You need to be matching the bandwidth with the Infinity configuration. So that's why you are selecting 200 meg in the dropdown. You can select the resource group. This is required by Azure. You select the resource group and click Create. Once you click Create, the resource is not provisioned, but it's in the creating stage. You click the resource, you can see the service key there. The service key, you can copy the service key and paste it back to the Infinity portal. Then you will be able to continue and configure your customer VLAN. So Azure Express Route supports 3 types of VLANs. There are Office 365 VLAN and public peering VLAN and private peering. In this case, we are supporting the Office 365 over the Express Route. We select the VLAN 3 for your traffic, and we need to select a secondary port for the diversity purpose based on Azure's requirement. Once you select the port, you will be able to continue for the next steps. Here is a summary page before you click the buy button. You are connecting from Equinix Singapore to Azure in Singapore. And your speed is 200 meg, and the customer VLAN is number 3. And the duration of the contract is 1 month, and it's auto renewal enabled. Then once you confirm all the details, you can click buy. After you click buy, you will be able to redirect to this page to view your service. The service is under provisioning. The orchestrator will be pushed the configuration to all our networking equipment and communicate with Azure portal directory. After a while, a few minutes, you'll be able to see this service is provisioned in Azure portal. And you can come back to the Infinity portal and see this service is provisioned. And you can check all the overview about the technical specification you have configured for the service and the secondary port. You can also configure the contract term, which is 1 month, and is auto renewable enabled. You can also check the SLA in the page, such as jitter latency. That's all for today. We have covered the interconnection in Asia, programmable telecom and adoption in the market, Epsilon's API story on Infinity, and DC Connect's integration. We finished the session with a Cloud Connect demo. We hope you find the session useful, and please get in touch with us on any questions. Finally, we want to thank everyone for your time today and wish you stay safe and take care. Bye-bye.